Hello guys. So let us look at this problem. This is related to the prefix sum technique. Given an array with n elements and an array Q with m queries, each query is represented as an array of L, R. For each such query, we need to find the count of even numbers in the range L to R. Okay, and both inclusive. So let's understand with an example here. Okay. So let's say this is an array A. Okay, let's put some numbers here. Okay, so we have an array A and an array Q. In Q, each element is actually a query. Okay, so this is query 1. This is query 2. Every query is represented as L, R. So L, R. L is 0, R is 9. L is 1, R is 5. L is 3, R is 7. L is 6, R is also 6. Okay, we need to find for each query in the range L to R, we need to find the number of even numbers, the count of even numbers in A. So let's say we start with query 1. For Q1, L is 0, R is 9. So between this range from L to R, how many even numbers are there? Okay, so 1, 2, 3, 4, 5. So 5 is the answer. Then we move to query 2. Now in this case, we are going from 1 to 5. So index 1 to index 5. How many even numbers are there? 1, 2, 3, 4. Answer is 4. Then for query 3, index 3 to index 7. How many even numbers are there? 1, 2, 3, 4. So again, for query 3 also, answer is 4. Then we move to query 4. Here, the L is also 6, R is also 6. So basically, L is here, R is here. So the range is only this much. Only one. It is covering only one index. How many even numbers are there in this range? Only 12. So which is basically 1. One number of even numbers here. So the answer will be 1. So we will return this as our answer. 5, 4, 4, 1. This array will become our answer. I hope you understood the question. Now moving to the methods to solve this. Okay, so now let's look at this brute force solution. So again, the same array, same query array, Q. The brute force solution is very simple. What we do is we iterate over this array Q. Okay, so let's say initially I am here. For each query in array Q, what we'll do is we'll extract L, we'll extract R. So if my I is here, then what will be the value of L? L will be clearly Q of I of 0. And R will be Q of I of 1. Okay, so whatever is the value of I, based on that, we'll go to that particular query. And then query of 0 gives us L, query of 1 gives us R. Okay, now I have L, I have R. So in this case, L will be 0, R will be 9. Now what I'll do is, I will iterate over array A within the range L to R. So basically just a simple for loop where we are iterating from L going up to R. And in each case, what we'll do for each element is we'll count the number of even elements, right? So what we'll do, we'll have a CNT which is equal to 0. And we'll increment CNT only if A of j is even. So if A of j is even, so how do you check a number is even? If modulus 2 is 0, then it is even. If this is the case, then CNT plus plus. And that's it. We'll have the value CNT, which will contain basically the number of even numbers in the range L to R in the array A. Then what we'll do, that CNT is part of our answer. So we'll have some answer array. We'll push that CNT into the answer. So in this case, from 0 to 9, how many even numbers are there? 1, 2, 3, 4. Anything missing? Earlier it was 5. Okay, so there is a 10 which is missing here. 0 is missing here. Okay, sorry. So 5 will be pushed. Then this part is done. In the Q iteration, the iteration for the loop for the Q array, I++ will happen. You'll move to the next query and repeat the same process. So let's see the code for this quickly. What are we going to do is first iterate over Q. So I will go from 0 to M minus 1. M is the size of array Q. In each case, we'll get L, which is equal to q of I of 0. We'll get r, which is equal to q of I of 1. Now that we have L to R, we'll have another loop, J loop, which will run from L to R. In this loop, we are going to check if A of J modulus 2, if this thing comes out to be 0, then this means A of J is even. And if it is even, then I have to do count plus plus. What is count? Okay, so I'll also have to declare a count which is equal to 0 initially. Once I have the count, I will simply do answer dot push this count. This is the pseudocode. So now that we have the pseudocode, now we need to think, is this the best solution that we can come up with? So how do you judge that? Basically just get the time complexity. So let's see, what is the time complexity? Clearly the outer loop is running m times. This loop is running m times. Okay, inside this loop, everything else, this part and this part, this is all constant work, but then there is this other loop. If I can know how many times this other loop is running, then I can get the time complexity. But that is not possible, just as in the case of the previous video's problem. Because this loop is dependent on L and R comes from Q is part of our input. We cannot know the input beforehand, hence we cannot know L and R beforehand. So I cannot judge how many times this J loop will run. It will run different number of times for different queries. And those queries will also change based on input. So what you do is, in this case, assume the worst case. Okay. So in worst case, how many times will the J loop run? So how do you judge the worst case? J loop is iterating array A. Okay. Array A has size n. So if a loop is doing only one work and that work is iterating over a particular array, then in worst case, it is basically iterating over the entire array. So in worst case, J loop is running n times. Okay. When will this actually happen? When L is equal to 0 and R is equal to n minus 1. So L is here, R is here. When this happens, then J loop is running throughout the entire array, iterating over every element of the array, and it is doing the maximum work. Okay, there is no case possible in which it will do more than this. Okay, so that is why we take n as our number of iterations for J loop. So time complexity clearly becomes big O of m cross n. Space complexity, we have not declared anything extra. Answer is actually an array. Okay, so answer is equal to empty array. In the beginning, we'll have to declare. But since answer is part of our output, we'll not consider it in space complexity. And space complexity comes out to be big O of 1. Is there a better way to do this? Yes, there is. Let's see that one now. Okay guys, so now let's try to solve this with the prefix sum technique. Now the question is, how do I know that I need to solve this with prefix sum technique? Well, actually I don't. Beforehand you will never know which technique is going to perfectly work for it. So you need to look for different patterns. So in this case, just remember that if the question is related to range, okay, like it is in this case, this question, if it is ever related to range, then give it a try with prefix sum technique, okay? It is possible that the answer will be right using this technique. Anyway, also you need to understand that the prefix sum technique is not much related to sum. Okay, it is more related to the prefix. Prefix is the more important part, not the summation. Because anyway, see, in this problem, we don't need sum, right? We just need the count of even numbers. Sum is of zero use to us. So if I make the prefix sum array as 11, then 11 plus 6, 17, and then I do this, this is useless to us, useless information. We don't need this. What we need is, we need the count of even numbers. Okay, so in our case, in this question, this is not prefix sum technique, but this is actually prefix count of even numbers technique. Okay, and based on different questions, this will change. It does not always have to be sum. This is what I'm trying to say. Okay, so earlier when array was this, you were doing prefix sum. So this became 2, then 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15. There can be a question in which you actually need the prefix product. Okay, not the prefix sum, but the prefix product. So what will you do in that case? You'll make the prefix product array, which is 1, 1 into 2, 2, 2 into 3, 6, 6 into 4, 24, 24 into 5, 120. Okay, this will become the prefix product array. In our case, in this particular question's example, we don't need the prefix product, we don't need prefix sum, we need prefix count of even numbers. So what this means is, up to index 0, how many even numbers? 0. Up to index 1, how many even numbers? 1. Up to index 2, how many even numbers? 1. Up to index 3, how many even numbers? 2. Up to index 4, how many even numbers? 2. This is what we need to do. And this is what we'll do for array A also. And we'll also see how to make this prefix count of even number array. Okay, so let's do this. Let's see. What I want is, I want to make the prefix array, but in this question's case, prefix of I is equal to count of even numbers from 0 to I. Okay, so in array A, from 0 to any particular index I, whatever is the count of even numbers, that will be present at prefix of I. Okay, so let's make it. So how to do this? Basically, if you know the program of counting even numbers in an array, then you know how to make the prefix array for this problem. Okay, so what will be the process of counting even numbers? You simply go to each particular index, check if it is even. If it is even, then you'll keep a counter which will be initially 0. If you find an even number, you basically increment this counter. That's it. What you'll do is, one extra step is, every time that this counter changes, you push it inside the pre-array. Okay, so right now, let's do this from beginning. Not only when it changes, actually in each iteration. Okay, initially count is 0, I is here. I is equal to 0. Is A of I even? No, count remains 0, push count. I plus plus, I comes here. Is A of I even? Yes, it is. So now count increases to 1, push count. I is here now. Is A of I even? No, it isn't. Count remains same, push I, push count. Then I plus plus, is A of I even? Yes, it is. Count increases to 2, push count. Then I plus plus, is count even? Is A of I even? Yes. Then count will increase to 3, push count. Then again I plus plus, is A of I even? Yes, it is. Count increases to 4, push count. Then I plus plus, is count even? Yes, it is. Is A of I even? Yes, it is. Count increases to 5, push count. Then again I plus plus, is A of I even? No, it is not. Count remains same, push it. Then again for A of 8, is this particular element even? No, it is not. Count remains same, push it. Then do it for the last element also. Count will remain same because 15 is again not even. So this is your final prefix array. Okay, so now that I have it, the question is almost solved because the rest of the thing remains same. Okay, so if I need for a particular, let's try the ranges now for the query. I'm at Q1. Range is 0, 9. So from 0 to 9, the number of even numbers is present at basically just prefix of 9. For let's say 0, 5, it is, if I want to find the number of even numbers between index 0 to 5, then it is simply present at prefix of 5. If I want from 0 to 0, then that is present at prefix of 0. If I want for prefix of, if I look at prefix of 7, this contains basically the answer for range 0 to 7. Now, let's take some other query which does not start with 0. Let's take this one. So, query is 3, 7. Okay. 3, 7. Now, the logic is again similar. I don't know the answer for this query, okay? The prefix array does not tell the answer for this query. It tells me for answer for 0, 7. It tells me answer for 0, 2 and 0, 3. It does not tell me for 3, 7. So what you do is, you just use your head a little. You know the answer for 0 to 7. You know the answer for 0 to 2. Okay. Let's say 0 to 7, the answer is S1. 0 to 2, the answer is S2. So this part, because after 2, here 3 will start. From 3 to 7, it is simply S1 minus S2, right? So what you do is, you just do 0, in this case, for this particular range, the answer becomes 0, 7, whatever is answer for this, minus 0, 2, which is basically prefix of 7 minus prefix of 2. Now, why do we do prefix of 2? Why not prefix of 3? Well, because if I do prefix of 3, then after subtracting, I'm getting 4 to 7. Okay, so let's write it this way in properly. 0, 1, 2, 3, 4, 5, 6, 7. Okay, so I have 0 to 7. I need 3 to 7. Okay, I need this sum. So what I need to do, from total, I need to subtract this part from 0 to 2. Okay, if I take 3 also, then I will get 4 to 7. I don't want 4 to 7. I want 3 to 7. Hence, 0 to 2 will be subtracted. And that is what we are doing. So the logic is actually pretty similar to what it was in the last question, okay, in the previous video. So we'll just do this. So basically, for any range x, y, the answer is either it is pre of y or it is pre of y minus pre of x minus 1. Which one is when used is basically decided on a one condition. Condition is this: if x equal to 0, then you go for this. If x is not equal to 0, then you go for this. This is the logic is similar to the previous video. This is because you cannot use this particular formula in both cases, because when x is 0, then 0 minus 1 will be minus 1, and you'll end up having this pre of minus 1. Pre of minus 1 does not work because pre is an array, negative indexes are not possible. Hence, when x is 0, then the answer is simply pre of y. Okay, now let's see the pseudocode for this. Okay, what will be the pseudocode? First, I need to write the part which will make up our prefix array, and then we'll use the prefix array to get our answer. Okay, so I'll just first make pre is equal to some empty array. Then I'll also have one CNT, which is initially 0. Then I'll run a for loop in which I will run from 0 to n minus 1. We're basically iterating over array A. I'll check if a of I modulus 2 is equal to 0. That means a of I is even. Then count plus plus. No matter if this condition is true or false, doesn't matter. In every iteration, I will always do pre.push count. After this loop is done, my pre-array is prepared. It is done. So now I'll use it. So again, simple thing. Take a J loop, iterate from 0 to m. M minus 1. I'm basically iterating over the Q array now. If I have it, now L will be equal to, again, this is just a similar thing that I wrote previously. R is equal to Q of I of 1. Now you have L and R. Earlier we were using a loop to get the answer for the range L to R. Now we'll just use our prefix array. So answer will be this: if L is equal to 0, then I'll have a, let's say, C here. Okay, I'll declare a C. Okay, if L is equal to 0, then C is equal to pre of R, else C is equal to pre of R minus pre of L minus 1. Okay, at the end, just do answer dot push this C. That's it. And you'll have to declare answer is equal to some empty array here. Okay. Now, let's basically get the time complexity for this. So this part and this part, this is all constant work. This is one loop going from 0 to n. So n iterations here. Inside is all O1 work, constant work. And then there is this other loop, which again, everything inside it is constant. It goes from 0 to m minus 1. So basically m iterations. So time complexity comes out to be big O of n plus m. Okay, again, space complexity will be big O of n because we have the prefix array. If you want to make it big O of 1, what you can do, you can make an in-place prefix array, okay? In-place prefix array, which I showed you in the last video. What you basically do is, you just overwrite the original A elements because we don't need the elements of array A anymore, okay? Look at these statements. We don't use array A anywhere. Once we have the prefix array, we don't need the original array A. So right now you have, let's say 1, 2, 3, 4, 5. What you do is you replace these elements with the count of even numbers up to their indices. So when you are here, how many even numbers are there up to this? 0. So this make it 0. Then do I plus plus. 0, is this even? Yes, it is even. So 0 plus 1 will be 1. So this will become 1. Then I plus plus. This is not even. So ignore and put whatever is the answer for the previous index, which is 1. For 4, this will become 2. For 5, it will remain 2. So it will become 0, 1, 1, 2, 2. Okay. And that is your answer. I've already shown this in the previous video. It is the similar concept. Basically, instead of making a separate pre-array, which you are doing in this case here, instead of doing this, you just overwrite array A. Okay. How to do this in this particular? Basically, you just remove this particular statement, and here you do A of I is equal to CNT. That's it. And you don't need this pre anymore. Don't need this. And instead of using pre here, you will have to use A. Okay. And in that case, this will become big O of 1. That is it. This problem is done. You learned two important things here. First is that prefix sum, when it comes to prefix sum technique, it is not about the sum. It is about the prefix part, okay? And second, you should think about prefix sum technique when you have range. You know, the keyword is range. Okay, that is it. Thank you.